Section 2.1 is on conditional statements. What a conditional statement is simply a statement that has two parts to it. It has an if part and a then part. An example would be if it rains, then the ground gets wet. That would be a conditional statement. Anything that has the word if and then in it. The hypothesis is the if part. The conclusion is the then part. Okay, conditional statements usually mean it's a conditional. One part is based on the other part. Okay, the conclusion happens if the hypothesis happens. That's kind of how it goes. The converse would be switching the hypothesis part and the conclusion part, leaving the if and then in the same places, but switching the two parts. So the converse of if it rains, then the ground gets wet, the converse of that would be if the ground gets wet, then it's raining. Okay? Sometimes conditionals are true, sometimes they're false, sometimes converses are true, sometimes converses are false. If you want to prove that one is false, you find a counterexample. We talked about those in chapter 1 a little bit, but we're going to talk about them a lot more in this chapter. A counterexample is just an example that shows that the statement is false. It proves the statement is false. The truth value is simply whether or not the conditional statement is true or the converse is true. It's just true or false would be the truth value. Okay, so let's try writing some of these. For example, here's a statement: white cars show dirt easily. If I wanted to change that into a conditional statement, the first thing I have to do is add in an if and a then. Okay? The second part you have to do is find the subject of the the subject of the sentence. The subject in this case is car. That's what we're talking about. We're talking about cars. The subject you always want to keep next to the if. So it would be if a car, or if cars, doesn't matter. If a car shows dirt easily, or if a car is white. The other two pieces then become the hypothesis and the conclusion. So it says white cars show dirt easily. So those are the two pieces. And so they're saying if a car is white, then it shows dirt easily. Okay, so now we've taken a sentence and changed it into a conditional. That if a car is white, then it shows dirt easily. You can decide the truth value of that statement. You can identify which part is the hypothesis and which part is the conclusion. Remember that the hypothesis is the part that goes with the if. So that would be this one. And the conclusion would be the part that goes with the then. The fact that it shows dirt easily would be the conclusion. And its truth value, if you can't find a counterexample, then it's a true statement. Okay, so if a car is white, then it shows dirt easily. That's true. If a car is white, then it does show dirt easily. So it's a true statement. If I write the converse of that statement, the if and the then and the subject stay where they are. So if a car, and then we switch the other two pieces. Okay, so we're going to take the it shows dirt easily, and that's going to become the first part. If a car shows dirt easily, then, and we would put it's white on the other side. Okay. All right, so that would be the converse of our conditional statement. Notice that the if and the then stay there, the subject even stays there, just the two pieces switch. Now, what's the truth value of that one? If a car shows dirt easily, then it's white. A counterexample would be something that, a car that shows dirt easily, but then it's not white. I would say that this statement has a truth value of false, because I can find a counterexample. If a car shows dirt easily, it could very easily be black. Or for that matter, any dark color car is going to show dirt easily. There's a pictorial version of if-then statements, of conditional statements. You've heard of something called Venn diagrams before, and you've seen them. They look like this, where there's a part and a B part, and then in here represents items that would be A and B, and then the outside would represent the parts that are neither A nor B. You usually see examples like ice cream. Those people that like chocolate ice cream, those people that like vanilla ice cream, the people who like both would go in here, and then the people who like neither would go in here, and then you'd put tallies or names or whatever if you were doing some kind of survey. For conditional statements, there's an if and a then part, the two parts. One is the if part, one is the then part. But understand that the if part, in order for a conditional statement to be true, the if part has to be completely contained inside the then part in order for the conditional statement to be true. If it's not, then there's a counterexample, and then it doesn't have, it's a false truth value. So in order to draw a Venn diagram of an if-then statement, one of the circles has to be completely contained inside the other, and that one that's completely contained has to be the if. Okay, so for example, if, and then the one we talked about was cars are white. So if you have a white car, and then shows dirt easily, and that's true, because if your car is white, then it will show dirt easily. There's no way for a car to be white and not show dirt easily. Now, out here, you could put other color cars that show dirt easily that aren't white. So this is where you would put your black car, because it follows the then, but it doesn't follow the if. That's how you know that the converse is false. If there are items that belong in here, then the converse is false. That's another way to look at it. Other than looking at it in sentence form, you can look at it in Venn diagram form. There are also some symbols that are used. You'll see them in a lot of the upper level math books, but they do show them in this book, so I want you to be aware of them. We read conditionals, if something, then something. That's how conditionals are read. And a lot of times the letters P and Q are used to represent the hypothesis and the conclusion. So if you see P with an arrow and then Q, that's the symbol for a conditional statement where the hypothesis is P and the conclusion is Q. Notice the arrow points at Q. We read this, if P, then Q. Sometimes you'll see other books say P implies Q, but for the most part, you'll see if P, then Q. Any letters can be used, it's just that P and Q are the most commonly used in books. The converse then would read if Q, then P, and the symbol for that would have the Q and the P switching places. So the Q is first, and then it arrows towards the P, as showing that that's the conclusion. If you get it in symbol form, a lot of times it'll be like this. So write if P, then Q, and then they'll give you values for P and Q. So in this case, our P value is x equals 5, and our Q value is x squared equals 25. So it says to write if P, then Q, write the sentence, and then decide its truth value. So for this one, it would be if, and then for P, we'd put x equals 5, then, and then the Q would be x squared equals 25. So if x equals 5, then x squared equals 25. Then you need to decide, is that conditional true or false? Well, that would be true. If x equals 5, if you plug in 5 and square it, you get 25, so it's a true statement. You can do the same thing with R and P and Q and P. Some of them are true, some of them are false. If R would be if 3x equals 15, then x equals 5. Well, if 3x equals 15, then x equals 5 would also be true. So this one would also have a truth value. And then you go on to the next one. Q implies P. If Q, so if x squared equals 25, then x equals 5. Now this one, you think about it. Let me write it out. If x squared equals 25, then x has to equal 5. If you think about it, there's another value that you can put in for x that when you square it, you get 25, but that's not 5. So this is where we're going to look for a counterexample. Okay, it's false, and my counterexample would be -5. If x equals -5 and I square that, I will still get 25. So the if part works, but the then part does not follow, which means it's a false conditional. Okay, that is the end of this lesson, and those are the homework assignments.